Welcome. We will be discussing higher voltage MOSFET switching using the IRF 630 and the IRF 9630. I chose those two MOSFETs because that's what I have and that's what I use in most of my projects for consistency. But this can apply to any MOSFET you want to use. Alright, this demo is fairly straightforward. I have an optocoupler. This is an N-channel MOSFET. This is a P-channel MOSFET. I'm driving two 28-volt light bulbs with a 50-volt source. The idea of this is to explain how some switching circuits will work, and then later we can apply those switching circuits to upgrading H-bridge motor controllers. But for now, the basic circuit here is tested and working. I can speed it. It's fast. The circuit's rather straightforward, and we'll get right to how these devices work in this configuration, and then you can decide if you want to use them as an application in your devices. Here is the N-channel MOSFET circuit with its associated optocoupler. Because we cannot exceed a gate voltage of 20 volts, if I want to switch this on without a separate power supply, I'm going to have to use a dropping resistor and a Zener diode rated at 12 volts. When 5 volts is applied to the optocoupler, the transistor switches on and I have 12 volts on the gate of Q1. This immediately creates a current path for the two light bulbs in series, and that's current, drain source, drain source. It's all the same through here, nothing to it. This is a very simple circuit. Like I said, select your dropping resistor for the Zener diode based on whatever voltage you're using. I have run this I used a 5.2K 5 watt. It was way overrated, but it worked fine. If you have a separate 12 volt or whatever supply, then you don't need this part, but this makes life a little easier. Do not exceed 20 volts or you will blow the gate circuit. Here is the actual circuit you saw in the video, switching a P-channel MOSFET on, and it's a little more complex, but not really so. We have, again, the optocoupler circuit. We have the same in-channel switch circuit. In this case, I just show it connected to 12 volts. You can use this resistor tapped off up here in the Zener diode to generate your 12 volts. I just put it as 12 volts here. What happens? My Arduino or whatever applies 5 volts to the circuit. The optocoupler transistor switches on. I've got 12 volts on the gate of Q1. Q1 switches on, and the current IZ flows through here. The difference is I have the Zener diode up here in this end of the circuit. With Q1 switched on, I'll generate 12 volts across the Zener diode, and you need this resistor here. As you do this one, these are the gate bleeder resistors. Do not leave them out, as some people have done and couldn't figure out why the transistors wouldn't switch off. But by generating a difference in voltage, 50 volts here versus 38 volts here, we'll switch on Q2, and there is my current path through the two light bulbs. That's all there is to it. Remember, your source goes back up in the P channel. Your source goes back towards your positive. I've ran this circuit up to 90 volts and it works fine. I just use 50, which is what I had on my prototyping setup. Fairly simple. Let's look now. I'm not going to fully discuss this H-bridge circuit, but here's the same Zener setup, 5K resistor and a switching transistor. It has two inputs, and that's pretty much it. You're using these instead of a voltage divider, you're using a Zener to assure that you have 12 volts to switch on Q1 and Q3. There I'm using transistor, and I had to go to a higher voltage transistor than earlier designs. This transistor is rated for 160 volts. It's a 2N5551. Or you can use this design. Make sure you drop in these two bleeder resistors. I replace both the bipolar transistors with MOSFETs, exactly basically the circuit you saw here. Here I'm not showing the optocoupler circuits if I choose to use them. But that's all there is to it. Two inputs, and you can switch them off and on. I'll discuss these particular H-bridge operations in a separate video, but this is what it would look like using all MOSFETs. And by the way, all the this, and this are all InChannel, same type. Or I can use the higher voltage bipolar transistors in this configuration. And you still need these 15K resistors. These are the gate turn-off resistors that keeps them turned off even if you don't have a voltage input. And that completes this discussion on MOSFET switches. I hope you find it useful, and keep up the good work out there, and visit my website at www.bristolwatch.com.